This video is how to visualize A cross V. A cross V. The vector A cross V is the vector Z. So what we are going to do is, please see the plane XY. I put it in yellow. Let me put it in red again, the plane XY. This is the plane XY. And both vectors are on the plane XY because the plane that is formed between A and V is the plane XY. So see the hand of the guy. If you rotate A through B, you will generate a vector C vector, that will go perpendicular to the plane in the direction done through the right hand, to the right hand by the rule of the right hand side. So it's something like watching from here. You watch from here, you watch from here. If you are here in front of the plane A cross V, you rotate A through B, and this rotation will make to go up. The other way that you can see, you can fix this picture in your mind, and you can see, okay, let's go to move this picture. If A and B change the plane, look at the plane how it changed. C will go in this direction in space. And A and V change, if the plane that contain A and B change, C will go in this direction. If the plane that A and V change, look at C. You see the plane A and V, and you see C. Okay, it's easy to see. So if the plane A and B change, look at this. Plane have changed in space. A cross B will go up. Will go up of the plane A cross B, but in this direction, see. You see the hands? You see the thumb of the hand? A cross B, A cross B, A cross B. In this way, you can imagine how to visualize the cross vector. So there are two things that I didn't explain when I did the cross vector and the cross product of two vectors. And the two things is that the magnitude of A cross B have a representation. The magnitude of A cross B is the magnitude of A by the magnitude of B by the sine of the alpha. So if this is A and this is V, what is magnitude of A by magnitude of B by sine of alpha? Well, this is alpha, the angle between the two vectors. What is V sine of alpha? Is this. This is V sine of alpha. Okay, and what is V sine of alpha? This by A is the area that is between the two vectors V sine of alpha and A. But this is the same area between this vector, is the same area here. So let me do it in another picture. So we have the magnitude of A cross V equal the magnitude of A by the magnitude of B by the sine of alpha. This is A, this is V, this is alpha, and this is also V, and this is also alpha, and this is also A. Okay, this is also A, this is V, this is A, and this is V. And what is A by V sine of alpha? Well, B sine of alpha is this length. B, magnitude of V, sine of alpha is this. And what is A, magnitude of A by magnitude of B by sine of alpha? The area between A and B is this area. This area. That, by the way, is the same area that this area. The same area. Okay, it's the same area. What is left here is what you add here, you miss it here. Okay? Okay? It's the same area. Let me do something else and we finish. Look at this, look at this. Oh. If A is the vector AX, I plus AYJ plus AZ, K, and V is Vx y plus Vyj plus Vc K. What is A cross V? Well, you make the multiplication AX, I plus multiplied by Bx, I plus Byj, etc., etc. So I cross I cross I is the magnitude of I by the magnitude of I by the sine of the angle. Sine of 0 is 0. Sine of 0, which is I. And I cross J is magnitude of the first one by the magnitude of the second one by the sine of 90, which is 1. So I cross J is 1, and 1 what? 1K. Okay, 1 in the direction of K because this is the rule. I cannot go. Look at the picture. Look at the picture. I, J, if you rotate A through J, will get K. Okay? So if you do all this multiplication, you will find AX, VX. A cross V, let's go to do it. A cross V will be AX, VX, I cross I, plus AX, Vy, I cross J, plus AX, Vz, I cross K, plus AY, Vx, I cross I, plus AY, Vy, I cross, J cross I, J cross J, plus AY, Vc, J cross K, plus AC, Vc, Vx, K cross I, plus AC, Vy, K cross J, plus EC, Vc, K cross K. But K cross K and I cross I, all these terms are 0. So this is the cross product. If I give you A and B, the component of the vector, you know how to find the vector. Let's go to do one example. Let's go to do one example here. But now remember that A cross K, A cross J is K. And remember that I cross K is minus I cross K is minus J. Remember that J cross I is minus K, and J cross K is I. J cross K and K cross I is J, and K cross J is I, and K cross K is 0. So if you regroup all these terms, you will get something that is on the next page. So A cross B, the result will be, I have to, I know, it will be, A cross B will be one thing in a component I, plus another term in the J direction, plus another term in the K direction. And this term is AYVC minus ACVY. Oh, good. And this term that is on the j direction will be AC on the j direction, bx minus ax vc correctly. I will tell you a trick how I imagine this, but you can see that you can make a pattern recognition. Look here. The I term that is, it will not involve here any x component, any ax. The I term will not involve any x component. So you go to the next of the x component is the y by c minus c by y. This term, j, the term that is here, it will not involve any ay or by component. So what is the next component to the y? Is the c, cx. So you go x, you go like this, x, y, c, x. So I'll go like this. This term will not involve any term in the y components. The next one will be c by x, x by c. Okay? And this one, k components, will be something like this, something like it will not involve any c component, so will be ax by minus vy ax minus bx ay. Okay, let me see if I go here. This is the c component, and here the next one is x, xy, yx. It's okay. I think it's the same thing that what I wrote before. Let me see if this is correct. Yes, it's correct. AY, BC. Let me see if this rule that I have invented is okay. I think it's okay. AX, I stop here. For example, if I want to find this is the X component, I will go to the Y, AY, BC, AC, BY. If I go to the J component, that is the Y, so I will start for the next one, C, AC, VX, AX, VC. Yeah, it's work. So if I go to the K components, I will go to the next one, X. So it will be AX, VY, AY, VX. Well, yeah, it works. So this is the vector. And it's exactly the same thing that I did a minute ago when I make the distributive property of multiplying everything and multiplying the vector A by the vector V. So let's go to do this problem. I leave you as an exercise because it's just to put it numbers. Let's say that A is the vector 3i plus 4k. 3i plus the vector 4k. And let's go to see that V is the vector, for example, is the vector 1i plus 4j. And I want to do the A cross V. So what I want to do first, I want to find the magnitude of A cross V. Oh, you can find the magnitude of A cross V, but you don't have the angle. It's the magnitude of A by the magnitude of V by the sine of alpha. So if you don't have the angle and you don't have any way how to calculate the angle that you do have, because you have the dot product between A and B to calculate the angle, but let's say that you don't have. Well, you make A cross V, as I said, and you will find a vector C. And the vector C has components I, some components J. Which component is the vector C? This one. This one is the I component. This one is the J component of the vector C. So if you want to find the angle between A and B, how you will do? No, you have to do it, sorry. You have to do the dot product. But you can find from here the magnitude of C. Oh, yes, you can do it. You can find the magnitude of C as the square root of this square, this term square, plus this term square, plus the other term square. You put it here, and you have the magnitude of C. So this is equal to the magnitude of C, and you can calculate the sine of alpha. Oh, of course. Let's go to do it. Okay, good thing to do. Let me think. 3i for K is, B is 1i for J, A is 3i plus 4K, and B is what is B? 1i for J. 1i for J. Magnitude of A is the square root, 3 squared 9, 4 squared 16, square root 5. Magnitude of B, 1 squared 1, 4 squared 16, magnitude or square root of 17 is the magnitude of B. So what is A cross B? A cross B is AX, AY, AX, Y, and Z. Maybe this rule, I think, is working. Eh? Let me check. I will check carefully that I didn't make any mistake. A cross Y will be some component in the I direction. What a component is in the I direction of A cross B? Is AY, VC, minus AC, BY. Okay? Some components in the J direction. So I'm in the J direction, and I'll go to the next one. So will be AC, Vx, AC, Vx, and I come back, minus, AX, VC. Okay. And some components in the K direction. So I'm in the K direction in C, so I start with the X. So will be AX, BY, minus AY, VX. Correct? So now let me think if I did it correctly. Yes, I did it correctly, for sure. Yes. So A cross B will be a vector C. Will be a vector C, and the vector C will be AY for BC, AY 0, AY 0 VC 4 plus minus AC is 4 by BY is 4, no? AC is 4 by BY, that is 4, yes, in the I direction. So this is the vector C plus something in the direction of J. The direction of J is this one, AC Vx minus AX VC. AC is 4, Vx is 1, so it will be 4 by 1 minus AX VC. AX is 3, VC is 0, minus 0. And on the K direction will be, the vector will be is here, AX, BY, AX is 3, BY is 4, is 12, 4 by 12, minus AY, where is here, minus AY VX, AY 0, by something, 0. So will be C will be minus 16i, correct, plus 4j, correct, plus 48k. If I did not make any mistake, it's too early, I didn't take any coffee, maybe I'm making a mistake, I'm sleeping. So the magnitude of C, you make it, is the square root of all this 16 squared plus 4x squared plus 48 squared. I don't want to do it, you do it. So you take this magnitude of C, and with this magnitude of C, it will help you to go to A cross V, which is C, is the magnitude of A by the magnitude of B by the sine of the alpha. It will be the magnitude of C. So you know the magnitude of C, you know the magnitude of A, you know the magnitude of B, so you can find the angle between the two vectors. Well, it's done. Sine of alpha is the magnitude of C divided by the magnitude of A by the magnitude of B. I think it's correct. Yes, I think it's correct. Well, try and make the same thing, making A dot V as magnitude of A by magnitude of B by cosine of alpha. And see if you can find the same angle, okay? Check it. So this is the homework. Homework. Check what I do, what I did is correct. Maybe I make a mistake in calculations. I don't know. You make it. If you got the idea, you can find the mistake. If I made one, I don't know. Okay, good luck. Well, just find the angle alpha here. Find the angle alpha here using this equation, and find the angle alpha using this equation, and should be the same angle. This is the homework, to find the angle, okay, and to check that there alpha is equal alpha, okay, whatever you calculate the angle between the two vectors, and this is in space. The other thing that I want you to mention is A is a vector on the plane. I think that I put it on the plane YZ. I think this is the vector A on the plane YZ, and the vector B, I don't remember, this is A, I think that the vector V is on the plane XY. So where is the cross product? The vector C, you make the plane between A and B in space, and the vector C is perpendicular to the plane. Okay, but I don't know if it's perpendicular to the plane. I think it's perpendicular to the plane, but going down, going in this direction. Because it's going up. It's going up. A cross B will go up in this direction. So you take the plane formed by A and V. Let me see if I can make a better picture here. So A is in the plane theta y, while A, I think it was like this, A, so A cross B go in the, okay, and V is on this plane is V. This is V. And what is the plane that form A and V? This plane, how can I draw this plane in space? Difficult to draw the plane, but C will go perpendicular to the plane. So A cross V, this is A and this is V, I said. A cross V will go perpendicular to the plane C, but I think it will go in this, well, it depends. If this is A and this is V, it will go down. So if this is A and this is V, A cross V will rotate and will go in a vector like this, C, going down. I don't remember how I put the A and V, but it will go, C will go perpendicular to the plane that form A and V. A and V form a plane, and the plane has a perpendicular, and C will go perpendicular to the plane. In that way, you can visualize to where it will go without any calculation like we did. Well, I hope this you will found clarifying the